Hi everybody. Now we're going to jump into section 7.4 homework, and I've got a couple of problems picked out here. So I think we'll go ahead and jump right in. The problem I wanted to work on first is number 2. Now what happens in section 7.4 is that the population standard deviation becomes unknown. Okay, you've seen this before. And when the population standard deviation is unknown, just note that this test statistic becomes a t-value, same as the critical value, and the p-value is going to have to come from a t-distribution probability table, not the normal distribution. So just switching to t is sort of all that's really happening. But degrees of freedom become an issue, and you just got to just do things slightly differently. But overall, it's the same process. Okay, so we're going to just go ahead and again do a quick rundown. This is a hypothesis test for a population mean. So the alternative hypothesis, you're testing the claim that the mean is either greater than, less than, or not equal to a value for a right-tailed test, a left-tailed test, or a two-tailed test. Respectively. The null hypothesis, you just change the inequality to an equal sign here, and that becomes your null hypothesis using the same value. Okay, and so I think we can go ahead and just jump right on in here. It says the following sample was randomly gathered from a population of quantitative data. There's no context here, so just a list of numbers. Tested claim of 4% significance. All right, and my alpha is 0.04. I don't know the mean or standard deviation, but it says that we're testing a claim that the mean is less than 5.5, the population mean. So that is mu less than 5.15. And the null hypothesis, it would just be equal to 5.15. Okay, like that. Now, I guess we can key these in here. So mu on the palette equals 5.15. And sigma, we're going to do mu is less than 5.15. There. Okay. Pointing to the left makes it a left-tailed test. Okay, so we're all good here. Now, at some point, they're going to need a sample mean, and a sample standard deviation. So I don't even know what the sample size is right now. So I think I'm going to go ahead and just paste these numbers into Desmos. We've done this so many times. So I'm just going to copy all this there. And I think we'll jump over, and that's a Command-C on a Mac or a Control-C. And then I'm going to jump over maybe a new window here to go to Desmos. Okay, and you could do this on your calculator, obviously, and maybe you should if you've forgotten how to do it. Let me go ahead and just launch the calculator here. I'll move the graph out of the way and just say A is equal to, and you have to use square brackets when you paste in these numbers. Looks like there's 31 values there, and I need the mean of A and the standard deviation of A. Oops. Like that. Okay, so those are all the numbers, and let's see if I can squeeze this a little bit. All right. So X bar is the mean. This is coming out to be 4.36. We should carry one place more after the decimal when we do averages. So this has one. These have one after the decimal. We're going to do 2 here. So for the mean, we'll go 4.36. And the sample standard deviation is 2.28. Okay. And it says my sample size is 31 here. Okay, so that's the bulk of what we needed to do. I think we jump back down to it. Are the criteria satisfied? Well, barely. N is 31, which is bigger than 30, so we can say yep. So I'll go say yep. criteria are satisfied. I think that's fine, yeah. Okay, so, and then now we got to compute this t statistic. There's actually a typo on here. This should say s, so I'm going to go back and fix that. By the time you get to this problem, this should be fixed. Okay, the formula should have an s right here. And if you look real closely, this has a sigma, so that's a mistake. I'm guessing that mistake is in all of the problems, so I'll have to go and fix it on all of them. No big deal. Okay, so we can put in our mean. Again, this is 4.36 for the mean. Sample standard deviation 2.28. The t-test statistic, I have not computed that, so we'll go ahead and plug in. So x bar 4.36 minus mu. Well, the mean from the null hypothesis is 5.15 over s, which is 2.28, divided by the square root of n, which was 31. Okay, so, and we'll round that to, I believe, 3 places this time. Okay, so we'll go ahead and punch that in. Fraction 4.36 minus, oh, by the way, I didn't mention, this is a left tail test. Just for the heck of it. Okay, so minus 5.15. Okay, and then over another fraction. So it's 2.28 divided by square root of n. N is 31. Okay, so negative 1 point. It's at 3 places, so we're going to go negative 1.929. Okay, do that down here. Looks good. And everything looks like it's correct here. Okay, now we got to do this whole test for statistical significance. So that depends on the alpha value. Our alpha is 0.04. Okay, and then we're going to get a critical value. Now notice, this one's a left tail test, as we say. So the critical value this time is going to be on the left. So I'm going to put a little mark here. And the area of that tail will be our alpha, which is 0.04. But it's going to be one tail. Now, remember, this is a t distribution, which uses degrees of freedom. So with 31 as a sample size, our degrees of freedom are n minus 1, which is just going to be 30 degrees of freedom on this one. So I'm about to go over to look up our critical value. Remember, 0.04 is alpha and 30 degrees of freedom, and it's a one-tail test. So let's jump over to that real quick. Oops. So here it is, 0.04, one tail there, 30 degrees of freedom way down there. So I think we have it, 1.812. Now that's a positive number. We're doing a left tail test, so we're going to make this negative. Again, it's 1.812. So let's go down, put that in. I'm going to make it negative. Okay, like that. Now you might note that our test statistic was negative 1.9-ish. So this guy right here is gonna land in the left tail. Just gotta land in some tail to be considered significant. It's to the left of negative 1.8, so it is significant. Okay, so we'll go ahead and let's see if we can answer some of this. Okay, so the t critical value, negative 1.812, like that. And yes, it's significant right here. Okay, check the answer, should be all good to go. Everything's correct here. All right, so then this is telling us how to do our p-value. The uncomfortable part is we have to use table A3 for the p-values now. Same thing with n-1 degrees of freedom. Now this is a left tail test, remember. So that's the easiest kind. We just go straight from the table. So we're going to have to round our test statistic to the nearest tenth. So, and let's just do a little picture of table A3 here. A little glitchy, hang on. Okay, so for the degrees of freedom, you just go out to, as usual, n-1, that'll be 30. Okay, and then the t-test statistic, you want to go down to negative 1.9. We round that to the nearest tenth, okay, because the table only goes to the nearest tenth. You have to, the top row is used for degrees of freedom, so it sort of limits things a little bit. So again, negative 1.9 and 30 degrees of freedom on this horrible, horrible table, which is right here. Okay, so I'm going to kind of do this. Here's negative 1.9, 30 degrees of freedom way over there. And this is just horrible, but anyway, it's better. It's the best thing we got. So, so for that p-value, we're going to use 0.0335. Don't forget it. I'm mostly talking to myself. 0.0335. And that represents that area to the left. So I'm just going to put this way over here. This is our test statistic. That's the negative 1.929. We rounded it to 1.9, so there's a lot of kind of approximate values that we're using here. Anyway, that's our p-val, 0.0335. And great, so p-value is 0.0335. I think we can answer some more questions here. Okay, so hopefully this will come out. Looks great. I want to emphasize here that this is just approximate. When I programmed this, I used the best software that I could get for it. How do I say this? The software I'm using is not as exact as it could be. And so sometimes the p-values aren't that great. These are really difficult computations, and the computer, whoever programmed some of it didn't do as good a job as I would have hoped. But anyway, enough of that. I'm just going to go down to a negative 1.9 here. Right there. Okay, and so this comes out as 0.033, which we came out with an 0.0335. That's pretty darn close. Just kind of painting the picture for us. So I think we're good to go here. And then it says, just to make our conclusion. So our p-value here is 0.0335. If I obscure the last two digits, maybe like that. Oops. Okay, so the 0.03, we want to focus on that. It's a little less than 0.04, and it That's all you need, just a little. So 0.03 is less than 0.04. That's our alpha. Okay, let me move that out of the way. Okay, and less means reject the null hypothesis and support the alternative. Okay, so I'll go ahead and check that off, and we're good to go. Okay, so everything should be great, and we got 9 out of 9. Very good. All right, so once again, I'm going to do a little cleanup here, and then we'll do one more problem. Okay, so now we're going to go ahead and jump up to question 6. This one will have context to it. Okay, so once again, make sure you know how to get the mean and standard deviation of a list of numbers from your calculator. You may be doing that on your next exam, so keep an eye on that. So what I am going to do here is, once again, I'm just going to copy these, and I'll paste them into Desmos. It says the following are hours worked per week for randomly selected employed students at Mount San Antonio College in Walnut, California. So let me just copy those, and then I'm going to clear out what I had in Desmos from before, and just restart it by saying A equals square bracket and then paste, close the brackets. So there's 41 values. I'll go ahead and put down N is 41. Okay. That means the degrees of freedom are 40. Okay, let's get the mean. So mean of A is 27.95. How many places? We have nothing after the decimal here, so we're going to carry 1. And I guess I have to say 28 point, if the 5 makes the 9 go up to a 0. So it's just going to be 28.0 on X bar. Hang on. Okay, and then my sample standard deviation. So this one, again, we're going to do one place after the decimal, so I'm going to just say 9.1 on that. With means and standard deviations, we carry one place more than the data had. So the data had nothing after the decimal. These are going to have 1. Okay, now let's go ahead and jump back to our problem here. So these are the number of hours worked per week. And it says test the claim at 2% that Mount Stack students work on average less than 30 hours per week. Okay, so the mean is less than 30 is the claim. The mean is equal to 30 is the null hypothesis. The alpha value, it says 2% significance, so alpha is 0.02. Okay, we'll go ahead and do our test statistic now. X bar is 28.0 minus mu, which is 30. Okay, over S, which is 9.1, over the square root of N, which is 41. Okay, I guess I could put in what I've done so far. So null hypothesis is going to be mu equals 30. And I think, again, less than is our alternative. So here we go, mu less than 30. Like that. That's pointing to the left, so this is a left-tailed test, like that. Looks good. All right, and then, ooh, I did do a good cleanup on my last problem. Let me finish that. Thought I did everything. There we go. Left-tailed test, so I'll leave that alpha equals and everything on the left there. Okay, so, and then criteria, are they satisfied? Well, your N is bigger than 30, so I can go ahead and write that here. 41 is bigger than 30. So we'll do a check. Could be normal, but we didn't get that. We just got greater than 30. Okay, and then give the sample mean. Well, the sample mean, we just have to do 28.0. Okay, sample standard deviation 9.1. Okay, now that t-test, let's check those to make sure we don't get the t wrong. So these are good. Okay, so the test statistic, we're going to go with the calculator now. Okay, so fraction, all I have to do is 28. I'll leave off the 0.0. The calculator does not care. Minus 30 over a fraction, 9.1, over square root. Where's it? There. 41, like that. So, and this one, again, the t-statistics is asking for 3 places. So we'll go negative 1.407. My alpha is a 0.02. And what I should be graphing here is my critical value. So is 0.02 one tail? Okay, this is a left tail test. Okay, so we'll go ahead and jump back and get our critical value now. 0.02 one tail, here goes. I think it was 40 degrees of freedom. So I'm gonna have to slide down here a little bit for that. Okay, so 0.02 with 40 degrees of freedom will be this. So should be 2.123 there. I'll clean that up. 2.123, I think I can remember that. Now it's a left tail test, so we're going to make this negative 2.123. Okay, and then you're trying to decide if your statistic, the test statistic that you computed, is statistically significant. So finally we get a problem that does not go into the tail. This negative 1.407 here is not as extreme as my critical value here, so it's going to be right in here. Okay, and it's not significant. Okay, so make this quick little note here on the problem. Okay, so the test statistic negative 1.407, and the level of significance alpha was 0.02. The t critical value negative 2.123. Okay, and yes, no, this time it's not significant, so no, not significant. Okay, check all that, looks good. Now the p-value. Okay, so the p-value is going to start at our test statistics. So real quick, let's just kind of sketch that in here. It's going to be a big p-value, so we got a big area here. And this is your test statistic, negative 1.407. So again, that's your t test statistic there. And just going to get that p-value. So we're going to have to do negative 1.4 on the table. Let's get around that. to one place after the decimal. It's 40 degrees of freedom, we decided up at the top. Okay, so we'll just figure out what is the area to the left. This is a left-tail test, so this should work out pretty easily. Negative 1.4 and 40 degrees of freedom. This is table A3. Okay, so it's kind of hard to read, but here's the negative 1.4. There's 40 degrees of freedom. And we'll see if we can line this up. So I think you can see it, but maybe not. 0.0846 is the area to the left of our test statistic. This is a left-tail test. What did I say, 0.0846? Okay. Okay, so I'll go ahead and put that in here. Everything's good. I'm going to draw it now. So we're just rounding this to negative 1.4. I think I got it right there. P-value, see 0.085, which is approximately what we got up here. And we are going to, this time, the p-value is 0.08. This one's greater than, hang on, it's greater than or equal, technically, than the 0.02, which was our alpha. So greater means, let's just say it's not less. So don't reject. The null hypothesis, and so don't support our H1, which had said that mu is less than 30. We can't support that, so the data are just not that strong. So we'll go ahead and wrap this up. We failed to reject the null hypothesis. We can't support the alternative, that's this first one. And so the data do not support the claim that MathStack students work on average less than. So that's your the alternative hypothesis that the data do not support. So we just want to check that off, and we should be good to go. Okay, so that's the end of the homework. Good luck, everybody.